Today we're going to talk about how to find the area of a triangle, assuming that we have a non-right triangle like these two. We've got two obtuse triangles. We're going to do the same thing with each. We're going to find the area. It's going to be a little bit different depending on the information that we have. But both of these, we have an angle and we have two sides that form that angle. And we're going to use that information to help us to find the area of the triangle. So on this first one, we need to remember that area is equal to 1/2 the base times the height. Now the problem with these triangles is we have the base, but we don't have the height. We've got a slant distance, but we don't know that direct height from top to bottom. So to help us out, I'm going to drop this down straight to the base of the triangle and form a 90-degree angle. And what that's going to allow me to do is to use the trig ratios we talked about before to help us to find the height of this triangle. So if I have a 27-degree angle here, I have a height which would be opposite of that 27-degree angle, and then the 15 would be what we could consider the hypotenuse of that triangle. So since we have opposite and hypotenuse, we can use the sine function. So sine of 27 is equal to the height divided by 15. So just like we've done before, to solve for the height, we're going to multiply that 15 over to the other side. So 15 here will divide out, 15 comes over here, and I'm just going to leave this as my height because I can take this entire expression and put it in right there for the height. So if I want to find my area is going to equal 1/2 the base, which is 10 for this triangle, the way it's oriented, times the height, which is this entire thing, 15 sine of 27. And then if I type that all in my calculator at once, I'm going to get that area, which is 34.0 feet squared. So even though we didn't know height to start with, we could figure out what that height was by using our right triangle trigonometry to find that height there. And I could do the same thing here. Even though I've got a different setup, I don't know that bottom left corner, I do know one of my angles, and I can use that to help me find the height. So I'm still going to drop this height down, and that height could be inside or outside the triangle, just depending on the orientation that you have. But looking at this, I don't have any angles inside that triangle that can help me out. So what I need to do is rely on this fact that I know a linear pair forms a 180-degree angle. So if I know this left angle is 120, what's left over on this right side would be 60 degrees. And now I have an angle that I can base my trig off of so that I can find my opposite side, knowing that I have that hypotenuse of 9. So when I set up this function again, the sine of this 60-degree angle is going to equal the height divided by 9. And just like we did on this last one, I can multiply that 9 off to the other side and get height equals 9 times the sine of 60. So to find my area, I'm going to take 1/2 the base, which in this case is 14, multiply it by the height, which was 9 times the sine of 60. And if I multiply those two together, I can figure out my total area, which is going to be 54.6 units squared. So in this first one we had units of feet, so I just put feet squared. The second one didn't have any units, so I just put units squared. Now both of these, we can find that area as long as we can figure out the base and the height. Each of these had a base. We had to use our right triangle trig to find the height.